Good day everyone. Today we will discuss about process cooperation and concurrent programming. Our objectives is to understand process cooperation, explain concurrent programming, apply symbolic constants in programs, and create a simple concurrent program with input and output. Now, what is a process? A process is a program in execution and it uses system resources. Of course, our CPU and memory. And the examples are browser, music player, games, and your other programs inside your computer. What is process cooperation? So, from the word cooperation, there are two or more processes that works together and they share data or resources. The common goal is to achieve a task. An example of that is the printing system. Multiple apps can use your printer. Your browser can use your printer. Your Word document or your Microsoft Word, Excel, and other applications can use your printer. Why is it important? Because it improves efficiency, enables resource sharing, supports communication between processes, and makes systems more responsive. What is concurrent programming? So concurrent programming is running multiple tasks at the same time, and it may run truly parallel or interleaved. And the goal is faster and smoother execution. Later on, we will have a quick implementation regarding this topic. Concurrency versus parallelism. So concurrency means tasks appear simultaneous, while parallelism, tasks actually run at the same time. The simple idea is that concurrency is multitasking, while parallelism is real simultaneous execution. So what are the real life examples? Downloading while watching YouTube, okay? So chatting while browsing, and then playing music while using apps. So these are concurrent processes because you can do this simultaneously or at the same time. These are the challenges in concurrency: the race condition, data conflict, synchronization issues. So example, two programs updating the same data. So these are very straightforward. Process synchronization. So process synchronization controls access to shared resources and ensures correct execution. These two are the common tools. So mutex and semaphore. So mutex is mutual exclusion. So it acts like a locking mechanism that allows only one thread to access a resource at a time. While the semaphore, it is a counter that allows multiple threads to access a resource up to a limit. Okay, so limited number of passes available. So mutex is strictly one at a time, while semaphore is limited number at a time. Now these are concepts, but in order to implement a concurrent program, we can use these symbolic constants, okay, interactive input, formatted output. We can use these to create a simple concurrent program that simulates concurrent processes. Okay, to do a simple concurrent program with input and output, We can use JavaScript because we already discussed JavaScript from our previous videos. You can search in my channel the JavaScript discussion. So let's create a sample code in JavaScript about symbolic constants, fixed values, interactive input, okay, accepts input from user, and formatted output to simulate concurrent process. Okay, so symbolic constants in JavaScript, we can use const. Let's say the max number. Okay, so let's create two functions. So function task 1. Okay, so these outputs a count of 1 to 5. Say let is equals to 1, and then should be less than or equals to max num, and then I++, of course. Let's use set timeout for you to see that both tasks are run at the same time. Let's give a space for each output. And then the second task, again set timeout. Let's just copy this. Let's just output but instead of 500, let's just give this below 500, and after the 500 is a remark. Now if we run this, okay, let's call first the wait, so this should be separate function. Okay, so let's run the function 1, the task 1, and then the task 2. Okay, so again, concurrent program runs these two tasks at the same time. Okay, if we run this, okay, so the program is interleaved, okay, or stacking. So instead of running the task 1 first, okay, so it outputs remark because the timeout is only 300, and then it starts the first task. That's why it outputs the number 1, but also it executes the task 2 at the same time. Okay, so this one is a basic example of a concurrent program idea. Okay, so you can just add interactive input for us to ask for an input. Let's use let name is equals to prompt, enter your name. Okay, and then let's use the name here. say hello, and then let's use, okay, let's just use this one, and then name. Okay, let's see. Okay, let's see. Okay, let's do this 400. So if I enter my name and then enter, okay, so even if task 1 was called first, okay, since it is a concurrent program, okay, it outputs the task 2 first. That is the basic implementation of a concurrent program with input and output. Now, back to our presentation. There are 3 ways to implement concurrency. So the first one is threading. The second one is async or await, just like what we did recently, the set timeout. So that is an example of the async or await. Then the multiprocessing. So in JavaScript, you can use set timeout, async, and await, but threading and multiprocessing can be used via Python. Okay, so an example. So we can code an example code for Python. Okay, that outputs or that simulates concurrency. We can code Python, okay, using threading. So same concept. It is used to run tasks at the same time. Okay, an example for that. Let's go back to our programming. Then let's use Python. Okay, so if you are knowledgeable about Python, okay, so this is a straightforward programming language without semicolon to end each line. And also you can use directly threading. So just import threading and then create 2 tasks. So that's same concept earlier, task 1. Okay. And then the for loop. Then the range is our max number presently, the 5. And then let's print. Let's print task 1. And then our variable I. And then the second task. Then again, the looping. So let's make this straightforward. No, there's no input. So let's assign value to each variables. So task 2, and then the same, our variable I, and then to assign each task into a thread, you can just say T1 is equals to threading dot thread, and then the target. What's your target? The task 1. Task 1. And then the second task. Okay, threading the thread. The target is task 2. Okay, and then don't forget to call each or to start, okay, each task. That's T1 the start. and then T2.start. So let's run this. Okay, same with our previous output. Okay, so the output is run at the same time. So that is threading. So that is one example of threading. So it runs two tasks at the same time and simulates concurrency by allowing task 1 and task 2 to execute in overlapping order. For us to better view that each task is run at the same time, we can add a time. So import time, then time.sleep. So as you can see, that both tasks are run at the same time. So that is a quick implementation of concurrent program. So both in JavaScript and in Python. So this can be also done in Python. So let's wrap this up. So the summary is process cooperation. So these are the processes that are working together. The concurrent programming, the multiple tasks at once, and then symbolic constants, the fixed values, input output, the interaction with the user, then the threading, the shared execution, the async, the non-blocking switching, multiprocessing, the true parallel execution. So these two on top is more on concept, and then the remaining below are implementation. So thank you very much, and that's all for this video. Goodbye.